Well, good morning, good afternoon, good evening, good night, wherever you may be across our lovely world. Thanks so much for joining us live here today for the one and only Serverless Office Hours. And we are streaming live on the AWS Twitch channel, on YouTube, Serverless Land, and also via LinkedIn Live. I'm Julian Wood. I'm a developer advocate here in the AWS team, in the Serverless team at AWS, rather. I don't even know where I work. What's going on? Must be the weeks coming up to reInvent where there's just scrambled brains with everything going on. But more importantly, I'm super happy to be joined by the one and only Jeremy Daly. And Jeremy, you are now the CEO and co-founder of Ampt, but rumor tells me that you've been doing serverless for a few years. So what's the journey to what you're doing now?
I started poking around with Lambda in 2015, right after it went GA. I started using AWS back in 2009. Discovered Lambda 2015, fell in love with the whole serverless paradigm, and I have been all in since. I spent quite a bit of time building other companies, building serverless applications in other companies. And then I did a bunch of consulting, and then I went and worked for Serverless Inc. for quite some time, and came up with this, really interesting idea with a few other of my colleagues to try to make serverless even better. And that's where we came up with Serverless Cloud, and we spun that off 18 months ago now. Wow. Technically we spun it off in June of 2022. And so now we're building Ampt.
Cool. Excellent. Well, we've got so much to hear all about getting Ampt, which Jeremy's going to be talking about. But just before we do, let's do a whiz-bang tour of the last week of serverless in AWS. Last week's stream was all about chaos, bring chaos into serverless, which some people thought was, hang on, what's going on here? But it's all about chaos engineering and Andre and Kensuke. And Kensuke was in Tokyo when he did it at 3 o'clock in the morning. Really nice stream just talking about chaos engineering and how you can do it with serverless. Lots of distributed services, different things to consider and look at. So yeah, really super info. And that's on our YouTube channel, youtube.com/serverlessland, along with all other previous Serverless Office Hours episodes. What's new in serverless? Normally, this sort of just goes up as the things come in. This is the past week. This is only the past week. reInvent's coming up in 2 weeks' time, which you're definitely going to chat about. But lots of stuff going on just from the bottom up because that's just in terms of time order. Some more error metrics in the init phase in your logging. That's going to be helpful for you. SNS just gets a big boost with lots of FIFO things. SQS for the JSON protocol. SQS, one of the original OG serverless services in 2006, has JSON support, protocol support, so even faster. Autoscaling for Kafka, that's going to speed up the starting from your Kafka processing. Amazon Linux 2023, a new base OS for a whole bunch of runtimes that are coming out, and for custom runtimes. EventBridge has got 20 new CloudWatch metrics, just much easier to work out how fast things are flowing through your event buses. And then the Lambda consoles had a quick refresh, looking at a single pane of view for the metrics, logs, and traces. So that's just literally the last week, and I keep having to refresh my my page because I know that some things are still to come out. Nudge, nudge, wink, wink. So I'm literally refreshing some of the browser pages to work out what's even going on this evening. So yeah, lots going on just in the what's new, and there are a whole bunch of blogs which are also talking about a lot of these things and some other kind of things. Just the top one up, the serverless attendees guide to reInvent, and Marsha and my team has put that together. And this is just not for attendees who are attending there, but also a list of all the breakout sessions, which will also be available on YouTube afterwards. So whether you are in person or not, just a useful blog post to catch up on all the things that are going on EventBridge. All the other ones are to do with a lot of the releases that have been coming out recently. Obviously, I have to mention the Kafka one because I wrote that blog post about scaling improvements with processing Kafka. So I've been deep in the Kafka weeds with Lambda for many months now. So lots of blog posts and many more to come. Then, of course, reInvent is coming up November the 27th to December the 1st in Las Vegas. Would love to see you. If you are going to be there, please come around and say hi. Lots of us are going to be there. Jeremy, you're definitely going to be there.
I will be there.
Things have changed. Yes. Jeremy will be there as well. So just I don't know, tens of thousands of people. I don't even know the count of the number of people are going to be going. But it's going to be a big show. If you can't join us in person as well, don't worry, there's going to be plenty of stuff, videos and things like that we're all going to be sharing during the week as well and after the fact. So hopefully you won't be able to feel too left out. But if you are there, it'd be super awesome to see you. I'm doing two talks and I will be buzzing around out and about. So it'd be lovely to see you, and the rest of the team would love to see you as well. Serverlessland.com as a learning page, just loads of things that are going on. In fact, there are a whole bunch of there's a page also about reInvent and all the various kind of talks. And I just did forget to mention, even if you are attending reInvent, only 80% of all the seats are booked. So there are still 20% walk-up space, and there's some pretty big rooms, so there could be hundreds more available seats available. So don't think if you haven't gotten a session yet, there's no chance for you. You may need to get there a little bit early and queue up, but it's certainly possible to be able to get in those breakout sessions. Before we get to that slide and talking to Jeremy, remember we are live on Serverless Office Hours, so we'd love to hear you. Tell us where you're from, what's going on. Farah Campbell, the wonderful, is here with us as well. Hi, Farah. How are you? We've got Lakshmi joining us via Twitch. Thank you so much. And then, AJ Stivenberg, he knows something about metrics. So many, you can't even count them from Datadog. He's also excited about reInvent, also excited about Ampt, and yes, he does love Ampt. So, Jeremy's already got the fan people joining in and joining us via YouTube. Dev Agrawal, thanks so much for joining us. So, Jeremy, why on earth would you need to build something called Ampt, and what does just write code mean?
Yeah, so it's kind of interesting in terms of where we were thinking about stuff. So again, like I said, I've been building serverless apps now for a very, very long time, and just to give you some background in terms of my experience, I started writing HTML in my dorm room in 1997. So I've been doing this for quite some time. Started with HTML, then JavaScript was relatively new. You couldn't do much with it, but we were starting to do some interesting things. And then I got into back-end coding using Perl and CGI bins, but I was using these were servers at the college, right, at the university I was at. And so it was you just, FTPing code back and forth. And then I got into, hosting companies and using those and so forth and writing code. Then we started buying dedicated servers where you had access through, control panel or something like that. Then I actually got to a point where we started buying our own servers. So we started racking and stacking those and putting them in the data center.
Do you have the scars on your hand from the cage nuts?
I still all the cuts from all the exactly right. Yeah, I mean every time I opened up a server, I would cut my hand. I was guaranteed. So I had my networking bag filled with band-aids and bandages just in case. But it was. Right. So we started doing that, and then we got into more complex networking, and I got into SAN disk arrays and blade servers, and then we were installing everything. We were running Spam Assassin and different services, and I was doing all that kind of stuff. Then I got rid of all that and went to AWS and started building stuff on virtual machines. So now I'm using EC2 and doing all that kind of stuff. And then we started orchestrating more things with Chef and Puppet and building things through ops work and doing all that cool stuff. And then serverless comes along, and you're like, wow, this is really interesting. Like, okay. And so I had the mindset, because I was very much so both an ops person and a developer person, and I'd already been using Chef and Puppet and those sort of things. So it made a lot of sense to me with CloudFormation, and obviously when the serverless framework came out, these were things that it made sense in terms of how I was, sort of setting up infrastructure. Yeah. Because now I was just like, and now I'm doing it more logically than I was actually setting up physical infrastructure. And so it became so much easier to do it that way. And for me, as someone who was an ops person, I was like, this is just, a breath of fresh air. It's great. Then it started getting much more complex, because the wonderful people at AWS just can't release something and be like, hey, this is good enough. No, you got to keep working on it and keep releasing. reInvent. This pre-invent season is my favorite / worst time of year, because there's so many amazing things that come out, and I don't have time to look at all of them and really breathe them in. So it won't be till the end of January till I figure out exactly what everything has launched around the reInvent time. But so things keep getting more and more complex, and you start adding more capabilities. And then, you've got great frameworks like the serverless framework or Arc, or even now the CDK and things like that, that now they start expanding. Okay, now you get different configurations, different options, right? And it's just, it becomes extremely overwhelming. And even me as a what I would consider, have a pretty good ops background, it just became overwhelming. And I remember, like, I started, again, I've been writing, code, the actual application code for quite some time. I remember getting to a point where I was like, I just want to spin up some new service. I forget what I was even writing. And I went to spin it up and I'm like, okay, so I'll just use the serverless framework. I'm super familiar with that. So I set that up and I'm doing that. And then I'm like, oh, wait a minute though. I really want a relational database. So, okay, well, I guess I'll have to set up a VPC and get RDS up and running and do these other things. And then you're thinking about networking and whatever. I mean, it was like a day before I even had my environment set up where I could just write a line of code that did something simple like, I don't know, respond to a HTTP request, right? And so that's where this thing started hitting me, where I'm like, why is this so hard? Like, what we're trying to do with the infrastructures, like I love that idea of just FTPing stuff to a web server and having it work. Now, granted, that doesn't scale and it has all kinds of other problems. But I was like, what if we could give that experience to developers and let them do that? So, if you're an ops person, then infrastructure as code may be, you might love it. You're in it every day and that's what you do. But if you're a developer and you're trying to build things in the cloud, I think it creates a significant sort of bottleneck, right? Where you're spending half of your time figuring out which resources I need and what are the right configurations before you can actually write any code. And that just, to me, is not the way that we should be building cloud applications. And that's why we said, what if you could just write code and everything, and it would figure out what you needed for your infrastructure behind the scenes?
So do you think, comes from a sort of history of building abstractions on things that have come before? And in a way, you build so many abstractions, and I mean, anything that runs in the cloud still needs compute, storage, networking. But we're building all these kind of abstractions, and in a way, those abstractions become cumbersome and become sort of calcified. That yes, you need storage, networking, and compute. But they're just, in a way, you want to compress all the abstractions and get rid of them, or what's your sort of framing on how things are built before in terms of creating a new paradigm?
Yeah, so
I hate the word paradigm, by the way. I can't believe I said that, but
it's okay.
I think you get the idea.
We'll excuse it. But it is we talk about serverless being a new paradigm as well. I mean, but I mean, I look at it, and I guess in terms of I actually completely blanked on your question. Sorry.
I was saying about as IT evolves, it builds on the things that have all happened
the abstractions.
Before.
I'm sorry. Okay, I've had a long day, so it's been a long. It's been I'm in the middle of a startup, so it's like you don't get a lot of sleep. Yes, the abstractions thing. Absolutely. So I mean, we continue to build abstractions, like you said, for pretty much everything, right? We don't do garbage collection manually on our code. We don't malloc memory anymore, right? Like everything evolves. I mean, if you think about, on-prem databases to managed databases, things like that, like we've built all kinds of abstractions that have abstracted away, both things that we have to do to physically configure it, things we have to do to manage it and stuff like that. And I think that what ends up happening with abstractions is when you build abstractions on top of abstractions on top of abstractions, right, you eventually will lose some you'll lose some of the granularity and the control that you need to do. But the interesting thing is that I don't think we built an abstraction. And I mean, I guess maybe you can call it an abstraction, but essentially what we did is we built a way for you to express what you want to happen, right? You just write your code, right? So it's just regular JavaScript or TypeScript code. There's nothing overly complex in there in terms of like, again, needing to know the services you use. But we tried to build it in a way that we said, if you just express your use cases, then all of the abstractions that you would normally have to build in order to make that work and all the abstractions you'd have to use, what if that's, I guess, just one big abstraction in a sense where you say, I've written an HTTP handler that responds to a request at /users, right? So what do I need in order to make that work? Well, the thing is that you can make that work in AWS probably 100 different ways, right? I can spin up containers. I could spin up EKS. I could use a Lambda function. I can use Lambda function URLs. I can use, API gateway version 1 or version 2. So there's a million different ways you could do that. So what we tried to say is, we get there's a million different ways to do those things, but why as the developer do you necessarily have to choose what that is? Because what we've actually found, and this is something where like I I guess, not to get too far off topic, but like CDK patterns, for example, or the CDK constructs, like a level 3 construct. So like a level 3 construct is like you end up writing a bunch, you combine a bunch of level 2 and level 1 constructs in order to create sort of a very specific pattern that somebody can deploy. And maybe there's, some flexibility in there and so forth. And it's great that you can do that, because now you can codify, a series of different services that interact with one another, and you can have the failover built in and some of these other things. But part of the problem is that abstracts away infrastructure that you technically need to know about, because you technically own, right? So just because it abstracts it away from you doesn't really do you much of a favor, other than making it easier to deploy something that you don't know what it does. And so unless you learn what that abstraction actually does and what the limitations are of each of these individual services, it's really hard for you to just go ahead and deploy something and then own it, because again you have that responsibility. So the thing is that the limitation is in the pattern that you choose. And what we find is that the pattern that you choose is super important, but that pattern needs to evolve. And where we see the evolution of a lot of those patterns happening is not so much in the use case, but actually in the volume or the throughput, right? So the pattern that you might use to respond to, say, a webhook that gets 10 requests per minute is a lot different than the pattern you might use if it gets, say, 1,000,000 requests per minute or something like that, right? Like you have to have different choices that you make. And the same thing is true of like, do I choose SQS over Kinesis, for example? Like, so what's the difference between a FIFO queue and Kinesis? Well, okay, Kinesis has some provision, is on demand and whatever. But when you get to a very high volume, Kinesis makes a lot more sense because it's cheaper, right? And you don't have to worry, because FIFO will get, or the SQS queues will get expensive. So how do you make that choice when you maybe don't even know what your volume is going to be, right? So if you're like, I'm building an application and I want to use this pattern because it uses this nice Kinesis stream for me and it orders it for me, and that's great. But if I only have, a few hundred requests per hour versus another service that might have, thousands of requests per hour, 1,000 requests per minute, which one do I choose? And suddenly I'm using a service that's probably not the right service for that volume of throughput, whereas it would be better if I did the other one. So to get back to the abstraction thing, the way we think of it is, if you're expressing your use case, if the system can figure out when to garbage collect or when to allocate more memory for you in a programming language, why can't the cloud figure out what are the right resources that need to be used behind the scenes?
Okay, so in a way you are, in a way you're actually abstracting the decision tree. So a lot of these decision trees on what fundamental building blocks of services, right. Ampt is going to figure that out for you, based inferring, I suppose, not just on your code, but also on your throughput or how you use the service.
Yeah, I mean, it's about the optimization, right? So we have a thing we call it smart compute, where essentially every time we deploy any JavaScript or TypeScript code to you, we deploy it to a Lambda function by default, because it doesn't cost anything when it's not running, and you can have as many developer environments or preview environments as you want. But then once that throughput gets a little bit higher, once I forget the number, I think it's like 15 requests per second. Like, it's relatively low, where if you have 15 requests per second, that is actually cheaper to switch to App Runner if you have if you have a consistent throughput, right? So those are the kind of things where you don't want to have to go and redeploy your code. And if you're building this and you're thinking, well, this is going to be a high volume, webhook or something like that, then you might, if you're writing it with CDK or something, you say, well, I'm gonna deploy it as App Runner, or I'm gonna do ECS and have it powered by Fargate or something like that. So that's fine. You do it that way, but then suddenly you do ECS, and then for every development environment you have, you're paying $30 a month for a load balancer, and then you've got these, now you've got all these IP addresses that you're gonna have to start paying for. So there's gonna be all those things that you have to do across potentially hundreds of developer accounts, and every PR branch you spin up, things like that. So we look at it and say, how do you optimize it for not just the throughput? Obviously, the use case is important as well. But this way, if you can guarantee that the pattern is adaptable, right? So the same behavior will happen, and it's just adjust based on the throughput, then we can switch those patterns behind the scenes for you based off of the actual traffic that your site's receiving or that your workload's receiving.
Okay. So, I mean, I think we should probably get onto a demo to see sort of how it works for people who want to do that. I will bring up your screen anyway. So this isn't just you're not just running an abstraction on deployment time, but you're actually sort of running a SaaS-based cloud service where people are actually going to run their apps on Ampt, and then behind the scenes, you're going to do smart compute and do a whole bunch of things to make sure that the code is running at the right place at the right time.
Yeah, so actually, we're not a SaaS, right? I mean, sorry, we're
Okay,
not a
cool.
PaaS. We're not a PaaS. So
Yeah.
we are. You're not running your code on us. So everything gets deployed to AWS. You can think of us as more of a deployment platform, like maybe like a Terraform Enterprise or a Pulumi Enterprise or something like that, where we actually manage the deployments for you. So
Okay.
the goal is really to give you the full power of the cloud. That's why we talk about these different, sort of what we call managed patterns, where we'll manage those patterns in your AWS environment for you so that you can maximize, the benefits of AWS. You don't have that graduation problem. But the sort of the SaaS component of what we do is the deployment piece of it. So I think
it's
maybe
within your own AWS account. It's not within an Ampt AWS account, for example.
Right. So this is one of the things that we are trying to figure out what's the best approach to this.
Okay.
So if you sign up for Ampt today, we will deploy it to a isolated AWS account, and we use isolated AWS accounts for every dev environment you have, every PR branch, every test environment, every production environment. Those are all separate AWS accounts. So what we do is we spin up those accounts on your behalf. We own those accounts as part of the initial, as part of your initial sign up and how you run your apps now. If you want to deploy to your own AWS accounts, the ones that you actually own, you can do that. So the distinction there is essentially they're fully managed AWS accounts. They're either in your name or they're in our name, but essentially the point is that it is deploying to, directly to AWS. So we don't really, we kind of call it the Ampt cloud when we manage the accounts for you, but really it's 100% powered by AWS behind the scenes. And so the things that we really have, and I probably should scroll down just because, again, this might be an easy way to explain sort of what the Ampt platform really consists of. So the environment management piece of the Ampt cloud or the Ampt platform is what actually does the provisioning for you. So this will connect to AWS, create new accounts, provision all the base resources that need to be in there, and does all of the management, all the security. That's all handled by the environment management piece. You mentioned infrastructure from code. This is the idea where you can literally just write code and you don't have to set up infrastructure as code. You don't have to do, CloudFormation or serverless framework or any of those things. And that is powered by what we call our runtime introspector. And essentially what that does is that reads in your application code and it figures out what it is that you need to do. And then it will go ahead and manipulate the infrastructure based off of what you've got configured there. We have our deployment engine that's built in. So we tend to think that CI/CD is one of those things that is hard to get right sometimes, right? It's always sort of a messy process sometimes to set up some of these CI/CD pipelines. So we have a deployment engine built in. So we'll just go ahead and take your code, run it through the runtime introspector, figure out everything that needs to be there, and then deploy that to the correct AWS account for you. And then our architecture optimizer is the thing that we were just talking about, where it monitors your applications, and when it sees the traffic get to a certain point. All of this isn't fully automated yet. Again, we just launched this into production, or launched it to the public about 2 months ago now. And so there's a lot of new things coming, but we're collecting all that telemetry and are able to go ahead and make those decisions to adjust things like memory and the patterns behind the scenes to make that work. And then we give you a full management console that allows you to actually see all of your apps, go in and look at the logs. All the logs get aggregated for you. You've got control over your data and your storage and your task management, all that kind of stuff is all built in there. So those are sort of the key components of the platform itself. But we very much so, we look at this as saying we want to be the tool and the platform that helps you deploy your applications to AWS.
Okay. And just to reiterate, it's JavaScript, TypeScript apps, and it's web applications. So this isn't, for web processing data processing or, all the other kind of things that you could think of a cloud is doing. This is specifically for JavaScript, TypeScript for building web applications.
Yes, we focus very much on web applications. There's a lot of things you can build in there. So we don't have direct support for like IoT right yet, but like but those are the kind of things that we will be expanding to allow you
Okay.
to, to do those sort of things. But mostly it's based off of writing, web applications, and things like that. We have eventing built in, obviously tasks, so you can run ETLs and that sort of thing as well. And then the goal is also to build as many integrations or open up the integration capabilities so that you can connect to whatever other services you want to connect to and enable to use and be able to use those. So yeah, so we have a couple of examples here, but I mean, I can just go ahead and jump in. Might as well just jump in and try playing around with the actual system.
Let's do it.
All right, so let's see if this is big enough here. So I'm just in an empty directory here, and if I ls, you'll see this empty directory, and then we have our Ampt CLI. So if I just run this Ampt command, you install the Ampt CLI. This will go ahead and say, where do you want to install which organization. These are my Ampt organizations. So I go ahead and select the organization I want to do it in. Say that I want to build a new app, and then we have all of these predefined templates that you can use, but you can just go ahead and use a blank template or create your own, right? There's nothing overly complex about that, but I'm going to use this Hono one because I'm not sure if you're familiar with Hono, but Hono is a web standard API framework. It's like Elysia or maybe like IDI router or something like that. So these are ones that are sort of built to run on the edge. So one of the things that we've done is we don't have a custom runtime. We originally started with a custom runtime. Now we're just running the base node runtime, and then we have some polyfills that come in that give you those sort of the web API standards, the polyfills in order to do that. Okay. So it gives you some pretty cool capabilities. So you can just use sort of standard API or web standard APIs or web standard frameworks to do some of this stuff. So I'm just going to call this, we'll call this AWS demo. And this will go ahead and generate a couple of files for me. So this is TypeScript. This has created an index.ts file, my package.json. Again, this is nothing. If you're familiar with creating a Node.js app or a Node app, this will all look very familiar to you. This is a basic TS config here. But essentially what this is doing is this is now spun up this URL for me that is loading my application. So the application itself is pretty simple. It's just using, again, Hono. And then, there's a hello route, there's a greet route, and then a post route. And then in order to basically enable this or to expose it to the internet, the way that these frameworks work is, or this particular one just uses this app.fire, but essentially this is just a shortcut for doing, for adding an add event listener for HTTP. So super easy to use. There's nothing you really have to think about to make that work. So if we go ahead and open this up, and this should open in, opened in the wrong. Oh, hold on a second. It opened here. Sorry, it opened in Chrome, and I wanted it to open over here. Let me just make Safari my my default so that it'll open in Safari. Okay, there we go. And let me open this again. All right, so this is just a basic static page that got generated. And the way that this works is we have a convention that anything you put in the static folder, we'll just go ahead and serve up through the CDN for you. And we'll talk about that a little bit more in a minute because we do some pretty interesting things there to make it pretty powerful. But if we're in this index here, so the /hello route, if we just go to /hello, then this will go ahead and serve up the hello. And then the other one was greet and name. So we'll do greet and we'll do Julian like this. And it just says, you can read that, hello, Julian. So what has happened here in just minute or so, not even a minute, is this has gone ahead and spun up a separate AWS account specifically for your application. It has generated all the infrastructure that you needed, including CDNs, the Lambda functions that power this. There's actually a bunch of other stuff for events and all these other things that are running behind the scenes as well. So this is all up and running instantaneously. Nothing you have to do, no setup at all, and it's just there. So clearly just a basic example, just with that to start with. But I'll stop there for a second in case you have any thoughts or questions on that.
No, interesting. We did have a start from Dev Agrawal saying Hono is amazing. Thanks. And then Chris Moyer asked, is there a benefit of using Hono over Ampt/API? So I suppose that's another part of the Ampt.
Yeah.
Yeah, that was a question.
No, that's a great question by Chris, actually. So the funny thing we were just talking about the other day, we're like, do we even need the Ampt API anymore? The reason why we built Ampt/API was because we wanted to have a web standards API framework that we could use with Ampt. And Hono and Elysia at the time were still a little bit, not quite where they needed to be. So using Ampt API, actually, we built Ampt API as a very, very lightweight, more experimental API just to show the functionality of using those web standards API. But we talked about this the other day. We're like, we should just recommend using Hono, Elysia, or something like that over it. So the benefit is Hono and the other ones that are out there, they have active development against them. We did the Ampt API sort of just to fill the gap, so that people had an option. So I would say use Hono over Ampt API.
Okay. Yeah. A question I was thinking as well is you've sort of got all these other plugins and Hono and things like that. But if people are coming from an existing web background and they are using, things like Flask, or they're using, frameworks like that, or Flask is a bad example, but, JavaScript frameworks and like that.
Right.
Now, how portable is that in terms of bringing existing code into the Ampt environment and use the simplicity of your system?
Yeah, it is. So it's very, very it is very, very compatible with all of these other frameworks. So one of the things that we did is we wanted to support as many of these frameworks out of the box. So actually, if I jump into Docs here and we go down,
I don't know why I said Flask when you're talking JavaScript, and I was thinking Express in the back of my mind. But yeah.
Yes. Yeah. No, we don't support Flask.
Exactly.
But like Next.js, for example, if you want to use Next.js, we have these things, we call them adapters. And it's just to make sure that it will wire up the HTTP requests, because they're all a little bit different. So you install, the Ampt/Next.js, and then in terms of, in the entry point, you just use this entry point in your index file, for example. Like it's pretty simple. And then same thing with like Nuxt. So if you're running let's say you're running an existing node-based API, right? So you're running Express or something like that. We have, one of the ways that our system works for you to interact with the cloud resources is by using our SDK. Our SDK is sort of like an abstraction, if you want to think of it that way. One of the interfaces we expose is HTTP. So you just build your Express app like you normally would build your Express app, but then rather than you basically having a app.listen on port 3000 or whatever you want to listen on, you just use this http.node.use, and that will expose your app to the web. But pretty much we have support for most of these now. So Next and Nuxt, obviously any of these front end ones, anything that you have a build step on that generates static HTML, those are all, those obviously are all supported. And then like 11T, for example. So if you're doing, got to update the documentation here, but if you're doing static site generation with 11T, that's all supported in here. And if you're doing SSR with something like Astro or Remix or one of these other ones, that's all supported. And we actually just launched a couple of weeks ago Next.js 13 support. So the features like App Router, React Server Components, streaming, and suspense, those are all supported now out of the box.
Okay. So then how do you think about the difference between front end and back end in this approach where it's very much merged? Well, from my looking.
It is, and you're 100% right, and that's one of the things where it was kind of funny because we thought we would just provide backend capabilities, and then what we found is that most people were trying to build they were trying to build much more complex, not just the backends but also the front ends that interacted with them. And actually, maybe this is something I can show because this is actually really interesting. So this is that simple app, right? It's just a simple, it's just doing HTTP routing, so nothing complex here. But what's cool about this is that if I was to add a new file under this static here, and let's say I'll call this test.html, and then here I'll just do h2 with my JavaScript, my HTML skills here, and I'll say, this is a test. All right, so I've saved this here. As soon as I save this, by the way, let me see if I'll show this there. As soon as I save, watch that little arrow down there. When I save this, it does a little quick spin, and then it gives me the check mark. That means that it's been synced. So it syncs pretty much instantaneously. It takes about 400 milliseconds or so to sync. But if I go ahead and I load this test.html page here, so I get, this is a test, right? If I make a change to this, so if I say this is a test 1, 2, 3, as soon as I hit save, it's synced, I refresh, this is live. This is live in your cloud environment, right? I mean, it's instantaneous, so you can do a lot of those cool things. But what's very cool about this is that these pathways, this test.html file, for example, this is loading because that test.html file exists. But if I just again load the hello route, for example, this hello route, this is dynamically generated from the API. So we're actually doing a thing at the CloudFront level where we use a manifest. We know all the static assets that you have, and then we're routing things dynamically based off of that. So you can mix static and dynamic routes, right? Which is really cool. Like with Ampt, for example, when you go into the docs page. So any of these docs pages that actually have a page, then it's perfectly fine. But if you were to run, if you were to load a page that didn't exist, it'll say we can't find that doc. So actually, this is a dynamically generated page. It's not just a 404 page, but because we can mix static and dynamic routes together, you can do some really, really cool things, especially if you're doing a bunch of, if you're using SSG to generate a bunch of things with 11T, for example, then you can mix those routes together. So, so in terms of answering your question, if you're doing the front end stuff, we're trying to make it as easy as possible for you to do front end and then have all that power behind the scenes so you can do the SSR or whatever else that you want to do. But we do have a significant amount of capabilities on the back end itself in terms of the things that you can do. So for example, like if you import our SDK, and let me do this. Let's do import events from... I have a love-hate relationship with Copilot because sometimes it gives me what I want, and then sometimes it gives me a bunch of stuff that I don't want to see. All right, so we'll import that, and I'm going to have to install it as well. ampt/SDK. And again, that just uses whatever packaging framework, your packaging manager you're using, right? So now I've installed this and I've got this events here. So when I load this this greet here, what I actually am going to do is it is async. So I'm going to await events.publish. And there's this publish, and I can call it anything I want, right? So I'll call it greet. And then I can send something with it. So I'm going to say name, and the name is going to be, well, I'll just do name, right? So this will send that name in as an event, or as the body of an event that's called greet. So if I do this and I don't have any way to listen to it, then it will just go ahead and just publish it, and it'll go into thin air and nobody will be listening for it. So the only thing that really matters is when I can actually listen for it. So if I do events.on, now I can listen for that greet. That will go ahead and load whatever data, whatever data is sent to it. And then I'll just do a console .log here and spit out the data. And I can go ahead and say, event or something like that so we can see it. All right, so now I've saved that. So now what I've just done is I've just created an event-driven application. So now if I go to, and let's see if I can keep this open so we can see both sides. So I will do, sorry, as I reorganize my screen here. All right, so I'm going to go back to this route that is the greet route. So I do greet and I'll do Julian again. So I fire off hello Julian, and now oh no, that's not going to work because I did greets. Let's try that again. All right, fire that off. So that sent a message to hello Julian, and then this should pick it up on this side as we just saw. And here's my event that came in, right, with the body, name, and Julian, right? So and there's a couple of cool things I can do around this as well if I wanted to learn how to spell first. So if I want to go ahead and fire this event off, I can also delay it. So I can say after 2 seconds or something like that. And just make sure I format it correctly. So now when I publish this event, and we'll change this to hello Julian 1, 2, 3. So I sent that event off, and now 2 seconds later, I get this instead of it happening instantaneously. So if it's just something you want to delay or something like that, you have the full capabilities to do that. The other thing that we built very early on were scheduled tasks. And when we built scheduled tasks, our thought was, we want to make this so that you just run something on a particular schedule. What we found out is that there were people who wanted to run the same thing on different schedules, or maybe run something in the background after a certain thing happened, and they wanted more control. So one of the things that we added with our task capabilities is we can actually spin these up in Fargate containers for you, and you don't have to do anything different. Like, it'll just happen automatically if the timeout is at a certain level. So if I create a new task here, so I bring in the task interface, then I can go ahead and write these tasks, and they're as simple as just saying const, we'll say, I don't know, my test task, and then, here's Copilot is actually filling it in correctly. So what I do is I just call task, I name my task, and then I provide a handler. And then anything I write in here, and I can also input data or something here as well, or have an event that gets fired. But essentially, if I just console.log this, I'll log task and whatever data comes out of it. So now I have this task that's defined. And the other thing I should show you too, because this is something this is all tied into the back end. So if I go into this AWS demo here on the back end, this is my dashboard, by the way. This is the environment that shows me all my environments. This is that test environment that I'm in right now, that developer environment. If I click into this is picked up that I have an event called greet. It has picked up that I have a task called my test task, and so forth. And if I want to schedule this task, all I have to do is just say my test task dot every, let's say, 5 minutes or something like that. And that's it. Now I've scheduled that task. And over here, this will go ahead and show me that that task has been scheduled. And I can actually run that task from here. So I just hit this to run it there. And then I'll go ahead and see that the task was run, and that, I get an execution ID, what the timeout was, how many attempts that it was configured to retry. It only actually ran once. But then I have, I see all this stuff. I have all the visibility. So I see that this test task ran. I can see all the details about it. So you can do this and just schedule these tasks to run every 5 minutes or whatever you want to do. Or the cool thing you can do is when you run one of these routes, like this one, like the greet one, we can actually just take that task. So we'll await my test task, and we'll just do .run, and I'll pass in that name. And so if I save this, clear that out, go back over to our greet over here, and refresh this, then this will go ahead and run that task behind the scene. But this is all asynchronous, right? So you can, and of course, you can set the timeouts for these things and stuff like that. So a lot of back-end capabilities that are just built in, and I don't have to worry about any of this stuff. So I don't have to set up Fargate containers or ECS or do any of that stuff. If I want to run a task for 45 minutes that does some sort of conversion thing, couple lines of code and I'm done.
Perfect. So yeah, that's why I sort of see the sort of combination of the front end and the back end. In terms of your terminal, because that is then sending the task information to your front end terminal, is that just using a WebSocket connection just as a terminal? It's not actually coming out of the API.
Correct. This is all through our control plane, right? Yeah. So the ability for you to do live logs. So we have live logs built into your environment. So it's just super easy for you to do this. There's nothing special you have to do. Once you have the CLI installed, we'll stream the logs back to you. But you also have in your dashboard here, you can actually go in and see any of the logs that were generated as well. So this will give you the detail of the logs that are spitting out as well.
So do people need to know what's doing the transport of these logs, whether it's Kinesis, SQS, SNS, Event Bridge, or does that not matter? Is that
so the logs themselves. So the only
well,
logs
I mean the logs. Sorry, the events. The events.
Oh, the events. Yes. So yes. So that's the point. Is that no, you probably don't need to know that. And that's one of the things where this is where we think we can add a tremendous amount of value by saying, did you pick SQS? Did you pick Kinesis? Maybe you did it through Event Bridge. Maybe you did it through one of these other ways. Maybe you did a DynamoDB stream. Like, there's just, why did I choose one over the other? And there are some guarantees, obviously, that you want, like at least once delivery and some of those other things, maybe the retries. So a lot of that stuff, we give you the ability to kind of configure like the number of retries and stuff like that. We haven't added ordered events yet, but that's one of the things that we're going to be adding soon. But the idea is that it should choose what makes sense for your use case as well as what makes sense for your throughput. So that's the goal of what we're trying to do here. And that, by the way, that scheduled task just ran on its own every 2 minutes, like we told it to. Or every 5 minutes. But yeah, so that's the goal, is to basically say, let the system make the best choices and learn over time as well, right? So it could be that, in SQS, we find that SQS isn't performing the way you need it to, and then that could shift over to something else if it needed to in the future.
Okay. So how does one, say you've got some of those routes with the API and then you want to read or write something from a database or, do something like that. How does then Ampt connect then to the rest of AWS rather than just within its own cloud?
Yep. So we have a parameters system that's a secure parameter system. So if I go ahead and I'll show you that. So anything you want to connect to, and let me see if I can. I'll just do return HTML. Oh, actually, I'll do this. I'll return this as JSON. Oops. And if I remember this correctly, you can just do params .all. I think that's right. Hold on. Let me double check the documentation. We have very good documentation, by the way. So if you want to look up that. So parameters, the options are, let's see here. I think it's parameters.all. Params. Sorry, as I look up how to do things. Well, I know you can do export. Well, let's try params.all, see what happens. All right, so if I go and I save that and I jump over back to here and we load /hello, internal server error, because that is not an actual thing. It's not a function. Okay, there we go. Now we know that. Let me try this. Okay, there we go. So that will spit out my parameters. So there are no parameters, right? So if I go into my dashboard here, I can go into parameters, and these are instance parameters. So I actually have to jump up to the actual app itself and do the parameters here, because parameters are all they all inherit, right? So you can put in organization-wide parameters. So if you had something that you wanted to share across an entire organization, you can do that. But so let me put a parameter in here, and I'll just, this is not something that you would, want to do on a live stream. So we're just going to fill in fake values here. But so let's say that we created an AWS token. We call it test123. We'll save this. So this token gets created and it actually gets populated into all of the instances or the environments that we're running. So when I refresh this, this should give me, unless it's not loading it because you actually need to specify it. Let me try this, AWS underscore. I know there's a way to load them all, but I can't think of it right now. AWS underscore / token like this. Let's try that. All right, so there's our test123 value that's there. So the way that the parameters work is that they get pushed out in real time. So you don't have to redeploy anything. So you would use these secret parameters to do whatever it is that you want to do. Again, if I go into my environment and look at the parameters within my environment, I'll see that I've got this one inherited here. I could override this. So let's say I'm in a dev environment and I want to do, oops. Why is that not letting me click in there? That's weird. Okay, hold on. Let me change it at this level here. So if I go ahead and change this to something like parameter, because I can't change. Oh, I know why I couldn't click in there. Okay, hold on a second. Sorry. Go in here, go to parameters and override. You can't change the name of the key because the key is what it is. But so now let me change this to 1, 2, 3. ABC. So I haven't redeployed anything. I haven't uploaded any new code, anything like that. As soon as I save this, this will go ahead and push that value out to the environment that I'm in. So when I refresh this, this will come back and be 1, 2, 3 ABC. So the idea here is that if you want to integrate with something in, let's say you want to use Memento or you want to use MongoDB, for example, you can put all of your parameters, your API keys, things like that, using the secrets management. And then you can interact with their APIs like you normally would, but all of your parameters, all of your secrets are managed there. Right now with AWS, if you want to communicate across AWS accounts that we're not managing, then you would have to put long-lived tokens in, which is something we're working to change right now. So we'll be using basically, I don't know if it's OIDC or one of those ways to generate temporary credentials every time your application needs to actually call into those other services. So we haven't done that. We haven't launched that yet. That is something we're working on. But if you are running existing applications or maybe you've got an existing database or things like that, then you can use these parameters in order to configure connections across different services.
Okay, so these are parameters that the front end, are these parameters that the front end's using or the back end's using, or is it just all merged now?
All right. So yeah. Okay. I can see how that can get a little bit confusing. So these parameters are backend parameters, right? So you can only access these via the server, right? So you can, and I say the server, now I sound old. So you can only access them via the back end and via your back end script. So I'm just spitting this out here on an API route just so that we can see it. So but essentially, these parameters. So
these are AWS tokens, secrets to connect to a database, for example, all those kind of things.
Right, and those will never be exposed outside of the back end. Right.
I mean, I suppose you can send them to the front end if you wanted to use something like feature flags or that kind of thing, where you could then have a parameter which you could expose via an API and use that, for example.
Right, and actually, a lot of people do. A lot of people use our parameters for feature flags because it is a very. I mean, I think about it this way: like, so if you're just, let's say we did something like this, we would say if I'll use AWS token, or I'll do this. I'll say if AWS, how about if we say if feature flag 1 equals true, then go ahead and return, whatever. Like, I mean, this is basic, but this would say like, text feature on, right? And then if not, it returns feature off, right? So now we save this and we can go here. When we load this, the feature is off because that doesn't exist. But then if we were to create this feature flag here, and again, this is actually what's one of the things that's really, really cool about the fact that it pushes the stuff out in real time for you, right? So you don't have to worry about redeploying things. So now I set this to true. and hit save. And now as soon as that's created, now this should be feature flag is on, right? So, and what's nice is, and this is just something I'll show, in terms of the deployment speed. Right now, this is just my developer sandbox, right? But if I did want to deploy this into something that I'll call it prod, this will say, you want to create a new environment. Yes, I do. So now this is deploying to a production environment. Now you can limit people from being able to deploy from their CLI, so you can just make it so it only happens, for CI/CD. But this takes about, I don't know, 14, 15 seconds. So it'll probably take longer because it's a demo. But this will deploy very, very quickly and create an entirely new environment. And in this case, this environment is a staged environment, or what we call like a real production environment. So this is one that wouldn't be ephemeral. Like this would live. So if I click on this and open this, so now this is a completely separate environment. And if I go to the /hello route here, so this is saying that the feature is on here, and I'll do this. This way you'll be able to see the difference between them. So if I go here, I'm still in. I publish this to my production branch, but what I'm going to do is I'm going to say feature off, and I'll use my 1, 2, 3 here, and then feature. Oops, I hit it. Feature on 1, 2, 3. 1, 2, 3. So now when I save this, this uploaded, but you won't see it here because this is my, this is my, okay. So this is the one, this is my preview environment, or my developer environment. This is my production environment. So yes. Okay. So in my preview environment, because I uploaded that on my developer sandbox, I can see that feature on 1, 2, 3. And then in this production environment, you don't see that. But now what's cool about this is I've got 2 environments that are using this feature flag. And if I'm at the app level and I go in and I change this feature flag and I change the value to false, then when I hit save, as soon as this saves, this has pushed that parameter out. So when I refresh this is going to tell me that the feature is off, but then also in this environment, it's pushed it out there as well. And this will tell me that the feature is off. So this is great if you're rotating secrets, or you've got maybe hundreds of developers working on, using an API key to access some third-party service. You can rotate all of those keys in every single environment instantaneously without them having to redeploy anything.
Perfect. Quickly before we need to go, Chris did ask, is each stage a separate AWS account too?
Yes, every stage is a separate AWS account. Yeah, I didn't even realize it went by this fast.
when you were deploying to prod, you actually spun up an AWS account in the background?
Yeah, so we pre-provision AWS accounts because again, it takes forever to do that. But I do now. I now have 2 environments in here. I have my sandbox and my prod. Both of these are deployed to AWS US East 1, but these are separate accounts. Yes.
Okay. And then Chris, Daniel, thanks for the question. Chris, on to Daniel. Can I see the architectural decisions that Ampt made for me and how it changes depending on needs within the Ampt console or directly from the AWS account console?
We are working on that right now because yes, that is going to be 100% transparent. You will see the decisions we made and exactly what is provisioned into your accounts. Yeah.
Okay. And then there's, observability and metrics and things like that. If we talk about Lambda, we're often talking about concurrency and throughputs and all these kind of things. Is that just sort of partly made simpler for you and then brought into your console?
Yeah, so the idea is for that to be abstracted away for you, so you don't have to worry about what your Lambda concurrency is set to. We do have some things where you can set within your code, you can set like timeouts and things like that as well when a particular route is being run. So there's some interesting things we do there, but we want you not to have to think about that stuff. So if you really want to limit concurrency because you want to limit it, then that's something we would want to give you access to do, but we wouldn't want you to have to be like, oh, I've only got so much concurrency and I want to share it across these things. It's one of those things that if you get to a point where you need more concurrency, we can just shift you over to something like, an app runner or, ECS or something so that you can have higher throughput without having to worry about some of those concurrency limits.
Yeah, and I suppose concurrency is also used to protect backend resources and RDS kind of things. So that concurrency decision is also not as simple all the time.
Right. And we've got some interesting things in terms of managing like downstream connections so that every feature that is in AWS, things like
You
EventBridge,
can expose,
you know, like all that stuff that you can do, you know, the APIs, or the what's the why can't I think of it? The API destinations, like
Yep.
some of those things. These are things that we are starting to incorporate into some of the features that we offer, so that again, those you can use all those amazing features of AWS without having to go and know that they were called API destinations, or that it even exists, right? Like that they're just there for you. Yeah.
Excellent. Well, Jeremy, thanks so much. Good luck with Ampt. It looks super interesting if you are a web developer. Yep. Wish you luck. We'll certainly catch up at reInvent, to talk more about it. And please send any questions and comments to Jeremy as well. Next stream next week is all to do with pre-invent. So we'll have the good and the great, and maybe some of the unwashed, talking all about reInvent and the things that have been going on and are going to be going on. So please join us same time, same place next week for that. But for now, Jeremy, thanks so much for joining us and taking us through Ampt. And Get Ampt is the website. There's information in the show notes which will help you to get Ampt. So thank you very much. Bye-bye, everybody. See you next